Again, my name is Chiam. I'm the Associate Director of Research Informatics at the Value Institute at Christiana Health System. And this big title was actually given to me. And I said, yeah, I can do with a title like this. So today I would like to share with you some topics in predictive modeling. And I would do that using an example that we use to solve some problems that we had at Christiana Health System a couple of months ago. And speaking of Christiana Health System, I'm guessing most of you probably never heard of us. Anybody heard of us? 1, 2, 3, 4 out of 5. Okay, awesome. So I brought this pretty picture of one part of our health system to share with you what it looks like. And we are situated in the state of Delaware. And my colleagues told me that I have to say the state of Delaware, just so that we all know Delaware is an actual state. We're kind of wedged in between New Jersey, Maryland, and also Pennsylvania. And we're actually one of the nationally ranked hospitals in the country in several of our specialties. According to Becker's Hospital Review, we're one of the top 20 largest healthcare systems in the country, whether we look at the count of number of beds that we have or the patient volumes and so on. We see about 200,000 emergency room patients per year, and that puts us into this category of big healthcare system. So my department, Value Institute, is a pragmatic research institute within the walls of Christiana Health System. We take on many different types of projects, anything from process and systems and process improvement to disease-focused type projects, as well as population health analytics and so on. And we do so based on the philosophy that no matter what we do, we have to be transitioning from volume to value. And we do so with a multidisciplinary different combinations of different skill sets together, including medicine, epi, behavioral science, law, industrial and systems engineering, statistics, as well as predictive modeling, which is my main topic of the day. So my main objective is to remind everybody that there's no such thing as the crystal ball. And, and some of the objectives that I would like to cover today include how to understand your data, how to create a predictive model, as well as applying some quantitative and simulation tools to your model. So some of you might be quite familiar with this analytics maturity model proposed by Gartner. They have it in the different forms, so I drew it, so I adapted from Gartner. And what basically this model says is that if your company wants to get to the stage where you can do predictions successfully, there are several things that you have to have in place as part of your infrastructure. Number one is you gotta have reporting mechanism in place to inform your system on whatever you want to be reported on, to answer questions like what happened. Then you can talk about analysis to answer things like why did it happen. And then you can do monitoring to make sure that you have your fingers on the pulse of your system to answer questions like what is happening. Once you have all these fundamental layers built in, then you can talk about prediction. How can we do prediction to answer questions like what might happen? There's another analytics firm kind of took this model and extended it by laying over this with a fifth layer called simulation. And simulation will help answer questions like what will likely happen. So I'm going to be covering prediction and simulation. And before we build any kind of predictive model, there are certain things that we really need to nail down before we even start doing any modeling. Number one is, what is that problem that we're trying to solve? Whether we call it problem definition or hypothesis we want to test, whatever it is, we really have to have a very clear idea of what that is. And that includes asking the right questions. From the perspective of predictive modeling, it's knowing what you want to predict. What is that outcome that you're trying to predict? So in different industries, there are different things that we want to predict. In healthcare, one of the things that we really love to predict is readmission, meaning if a patient is discharged from your hospital, what is the likelihood, or is this patient going to come back to your hospital within 7 days, within 30 days, or whatever time period? And the reason that is so important for us is, number one, it is an indication of the quality of care that we provide. Secondly, hospital systems reimbursement is actually tied to our readmission rates, reimbursements from payers, from agencies, and so on. So there's a direct hit to the bottom line if this number is not good. The next kind of outcomes that we like to predict is adverse events. So adverse events could be whether or not a patient going through surgery is going to die after the surgery, or if the patient is going to have some sort of complications, whether it's after chemo, after heart surgery, and so on. And the reason that's important is because once we're able to make that kind of prediction, we'll be able to build our processes in place and allocate our resources in strategic portions of the hospital to ensure that those kind of things don't happen or prevent it from happening the best that we can do. And in other industries, there are specific things that they like to predict. In the aviation industry, airlines like to predict passenger volumes and also what are the passenger cancellation rates. So that will inform them on how many seats they can double book and oversell. In manufacturing, we heard, I heard several comments already in this conference about wanting to predict things like machine breakdown, sensor breakdown, and so on. And one of the reasons for doing that is that you can schedule maintenance ahead of time in order to fix your machines or prevents the breakdown so that your production volumes are able to meet your sales goals. But in general, no matter what kind of industries we come from, there are things that are just fundamentally similar to all of us. Things like, can we predict cost? Can we predict revenue, profit, charges? Can we predict number of resources that we need? For example, people, FTEs. So the example I want to share with you is actually an example on FTE. In this case, we want to optimize the number of hospital-employed language interpreters and also predict the cost to the organization. So hospital interpreters, literally, they are people who are either bilingual or they are very professionally trained in multiple languages because we see a lot of patients, either language is not the first language or language is the first language, but they prefer to understand their health conditions in a different language. So these interpreters are the people who provide that kind of services. So that touches on stages 4 and 5 of the Gunner's model. So as I mentioned, before we build any kind of predictive model, we want to be asking the right questions. And the way this project started was our CFO as well as our corporate director of finance. Some people call him the hitman because his job is to shoot down budget requests. So they came to our department. Am I on tape? Oh gosh. Speaking of the truth. So they came to our department and they said, we've been spending a lot of money on the Department of Language Services, and we've been doing that year after year, and we don't really know how much we should be spending. We don't know what that ceiling is, and every year they come to us and they ask for more money. So about 2 years ago, they said to the Department of Language Services, they said, you know what, we're gonna stop right here. This is how much you got last year, this is how much you're getting this fiscal year and going forward. So when Language Services got that message, they were really bummed out because as we talk about communication being important and everything, they really do provide that bridge for communication between patients, families, and their providers so that they can understand the health conditions, they know what to do after they leave the hospital, preventing readmission and all that. So from Language Services perspective, finance does not appreciate their services. So we talked to Language Services, finance came to talk to us, people take each other out to lunch and talk about all that and what to do. And after some conversations, we finally figure out what is that problem they're trying to solve and what is the question they're trying to ask. The question is there a way that we can figure out what is the optimal number of interpreters we need, and is there a way for us to predict the corresponding cost of the hospital? The way it works in our hospital is that our hospital employs our own interpreters, and we also utilize agency or contracted interpreters. And the way it works is that when we have a demand for interpretation, that demand will go to our own interpreters first. If they are not able to take the demand for whatever reason, labor shortage or whatever, their request will go to agency, and of course that becomes an expense. And no matter what kind of projects that we take on, our projects have to satisfy our strategic goals, which is summarized by our what we call the annual operating plan. First is optimal health. Anything that we do has to have an impact in terms of promoting health for our patients. It has to promote exceptional experience for both our patients as well as for our staff. There was a speaker yesterday who talked about patient experience in the emergency department and so on, shaving time off and taking waste out of the system. And this is another way to promote experience for our patients as well. And the third is organizational vitality. Really what it means is we have to be cost contained. It's the $ there. So once we have our problem figured out, once we have our questions figured out, then we gather our data, extract data from multiple IT systems. That itself is a different presentation. But then we have our data, and we want to be able to understand our data. And whether we're talking about healthcare or any industries, when you gather your data, the desire is to let's do something with the data and let's construct something with the data. But we have to go through steps, due diligence to figure out, How does our data look like? So we like to plot our data. And that green line is actually the demand for language services over 2 years. And we can see without a trend line that demand is going up, which is why our language services have been asking for more money and more people. And we also want to make sure that we check for missing data, understand why data is missing, check for duplicate data, check to see whether data is captured in a consistent format to allow for more efficient analysis. And very importantly, is this the right data to answer the question, to fix the problem that we're trying to fix? And once you go through, or we go through all the data, now it comes time to choose the right model. So when we talk about FTE, optimization, and cost prediction, if you just Google those words, you're going to get thousands of hits on Google. But the thing is, just because a model works for somebody doesn't necessarily mean that the model will work for you. So in our case, we didn't see any models that actually fit the case that we're trying to fix here. So we ended up developing our own models and put together our models in a specific way to solve our problem. So one of the models that we did was a mathematical optimization model. And what it does here is pretty much minimizing the deviance between supply and demand. So supply of interpreters and also demand for interpreter services on an hourly basis subject to a bunch of constraints like interpreter, if you were to assign an interpreter to a shift in a day, you cannot assign he or she in 2 shifts and so on. So we solved this mathematical model, we got a set of solutions and also the corresponding schedule. And one of the key main advantages of using mathematical optimization, and I have to say the word optimization is used very loosely and sometimes abused nowadays, but when we talk about mathematical optimization, one of the key advantages is that when you get a solution from it, you can be sure that whatever you do in your system, however you implement it, the processes you build behind it, your ROI is not going to be better than what math says because that's theoretical optimal. And because of that, one of the key disadvantages here is that when you build this type of model, there's an underlying assumption that you understand all the variations in your system and you build that in here, or your system has 0 variation. And from our previous talk, there was a comment on variation as well. So to counter that variation, we use another quantitative tool, what we call discrete event simulation. And it's a computer simulation that we built on top of our math that introduces probabilities into the data that we capture into the math, because then we can ensure that a model will mimic our actual system in a more accurate way. So this is actually a little animation of the simulation. So you can see these little people running around. They are the interpreters. They go from one part of the hospital to the next part to provide their services. And once they're done with their service, then they will check and see if they have a pending service. If they do, they go to that part of the hospital. If not, they go back to their home base, which is that M in the lower left corner. So this little clock right here is actually the clock time. It's simulating the time of the day. And one of the advantages of doing this is that if we ask the question of what does our system look like 3 months from now, we can actually advance time and capture the outcome from the system. And when we did that, it took about 15 seconds in the simulation for us to really look at what our system looks like to make that kind of prediction. And even though we're talking about healthcare and interpreter and so on, this type of method can be applied to things like supply chain or supply network, because it's more than a chain nowadays. And also your manufacturing floor, assembly line, call center, whatever process that you're trying to study that has some sort of flow in your system. So this type of model will require some specific types of input. So the input into this type of quantitative tool is, for us, it's a spaghetti diagram that we captured through a time and motion study. And we also capture time duration, value-added, non-value-added activities. We capture demand arrivals for, in terms of hour of the day of the week. We build all that into the model. And then we had the mix of languages, which you can think of it as mix of products, mix of services that comes into your shop. And also we have the optimized FTEs and schedules that we solve from the math. So we took all that, put it into our simulation model, and we took the output of the simulation model and stick it into a cost model that we built based on cost model of our own interpreters and also cost model for paying our agency interpreters. And we did the analysis, and this is what the results look like. So the x-axis here is the count of number of FTEs that we had. The primary y-axis, we call it cost ratio, but you can think of it as total cost, total direct cost, the hospital. The secondary y-axis there is the volume to agencies. So intuitively, we know that as we increase the number of FTEs, the red line, which is the volume to agency, will decrease. But using predictive methods like this, we're able to quantify what is that decrease and how many of them are there that corresponds to each level of FTE. And because we're able to do that, we're able to quantify what is the total cost to the organization. When we started this project, we were at somewhere around here, so that was our total cost. And using these quantitative predictive tools, we're able to predict that as we increase the number of FTEs, our total cost actually decreases, which is kind of counterintuitive. And we saw that our optimal point is at 10.5 FTEs. If we were to keep hiring, our total cost will then increase. So this corresponds to a predicted amount of about 10% cost savings, direct cost to our organization. So we proposed this model, we showed the approach and the model to our finance department, and they were actually very open to this, and they approved all the FTEs that we recommended, even though at that time we were having a hiring freeze. So the approval was something that we couldn't talk about at that time, but now we can talk about it. Politics, you know. So the additional Spanish and Mandarin interpreters were actually hired as of this past Monday. They actually threw a welcome party for the new interpreters, and they threw a thank you party for us. Unfortunately, I wasn't able to be there because I was on my way here, but ironically talking about this project. But I enjoy being here. And just like any kind of implementation, we don't want to just plop and run. We do want to evaluate our implementation. So we are collecting data to look at what is the observed health outcomes of our patients with limited English proficiency, and also what is the financial outcome to the organization. Is that something that, you know, as what our model shows, so how does that compare? So in conclusion, I want to say that, again, there is no crystal ball, and I want to leave you with a quote. So this quote is something that I came across when I was in grad school studying about predictive models and constructing models and that kind of thing. And it was a really hard pill to swallow because the quote says, all models are wrong, but some are useful. So why is it that all models are wrong, some are useful? That's another big discussion. But the guy who came out with this quote is Dr. George Box. He's a statistician. When he came out with this quote, he actually referred to statistical models like regression and machine learning, artificial intelligence, and all that stuff. But as you think about it, this quote actually applies to your business models as well. The keynote from Google this morning said that when they talk about Lean Six Sigma and all that in Google, it's not a very well received kind of thing because they have to adapt that to their system. They have to change the way they use those models in order to make them useful for Google. And in general, when we're talking about predictive modeling, again, we have to, in order to make our models useful, we have to go through the due diligence of asking the right question, know what problem you're trying to solve, really understand your data, choosing the right model. Just because a model works for somebody else, your competitor, doesn't mean the model is going to work for you the way it works for them. So you want to choose the right model. And we also have to go through the due diligence of evaluating and challenging the model consistently. Whether you are the person developing that model or you're the person who is receiving the model from somebody, you want to always challenge the model and evaluate them. And depending on what that model is, there are different types of evaluation. And we can get into more details later as well. So in closing, I just want to acknowledge our CFO, Tom Corrigan, for starting the project. Our Chief Health Equity Officer, Bettina Riveros, for supporting and sponsoring the project. My colleagues, Steve Hoover, Danny Mosby, Dr. Kaplan, Dr. Combe, for contributing to the project, as well as my Department Value Institute for all the collaboration and input to this project. And with that, thank you.